In this video, we are looking at exponential functions. Our objectives are to graph exponential functions and to apply exponential functions to compound interest. So let's get started. I want to present the definition of an exponential function. It's going to be a function of the form y equals b to the x power. Now, b has to be greater than 0, and b cannot be equal to 1. That is the definition of an exponential function. I want to make something very clear here. Notice that the variable x is located in the exponent position. That is a trademark, a key characteristic for exponential functions. What we're going to do here in this first example is graph each of those exponential functions, and in doing so we're going to better understand what the b value does to your graph. So I have open here my little graphing calculator application so that you can see how it is that we graph these exponential functions. I've selected the y equals where my graphing capabilities are, and I'm going to type that in. It is a 2 and it's raised to the x power. I have to use this variable x button and then press enter. I also want to change my window just a little bit here. I'm going to have this as a -5 to 5. And for my y minimum, I only need a -1. And we'll go up to 10, that's fine. This SLC, that's scaling by 1 each time. Okay, so now let's look at the graph. A little bit closer picture here. There you see the graph looks like just a really steep curve, but over here it is really flat. And let's take a look at the table. So I'll press second table. Now we can understand the values a little bit more. At 0, the output is 1. At 1, it's 2. At 2, it is 4. At 3, it is 8. Each time that we increase, check out what happens. If this is our x position, the y position starts at 1, and then it is 2, and then it's 4. Each time it is doubling. Now check it out. Here if we go the other way, it's decreasing. This is pretty wild. Those are really, really small numbers, but I could zoom for a long time and it's never going to actually show 0. It's going to be 0.0000000000003, but it's not 0. That is the amazing thing about this graph, which I'm going to go look at again. This graph, it is getting so close. It looks like it's touching the x-axis, but it doesn't. We're going to define what that means in just a little bit. But let's graph another function here. Let's graph just below, let's graph the 3 to the x power. And take a look at the graph there. So that was our original, the first one. Here is the next. Notice that it is steeper. Let's look at the table so we can understand their values a little bit more. Go back down to values that we understand. Okay, so they both At 0 are 1. But then at 1, we had 2, now we have 3. And then it's 9 at 2. At 3, it's 27. At 4, it's 81. At 5, it's 243. So quite a bit steeper. Those y values are quite large. And let's look at what happens each time. It goes from 1 to 3, 3 to 9, 9 to 27, 27 to 81. In this graph, y equals 3 to the x. Each time that you increase your x value, it is multiplied by 3. So that base value tells you how your y values change each time. If it was a 2, they double. If it's a 3, they triple. But what happens when it's half? Let's take a look. I'm going to pair the 2 to the x, and I'm going to change this to be the, I'm going to change this to be the 1/2. So we can see those side by side. Okay, and let's graph those. There's our first one, 2 to the x, and here is 1/2 to the x power. All right, you should see right here we have some beautiful symmetry. Instead of going up, 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 now what's happening as we move from across our graph, we're going down, 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 down. Let's look at the table. At 0, they're both 1. Now for the equation 2 to the x, we doubled, remember, each time. But here what's happening is we're taking half. Half of 0.5 is 0.25. Half of 0.25 is 0.125. If I go this way, you'll see as we move, as our x values increase, we went from 16 to 8. That's half of it. 8 to 4, half. 4 to 2, we again took half. 2 to 1, now we've divided again by half. So let's look at the graph one more time. When your b value is like this, a fraction, you're actually going to be, each time you move, each unit, you're going to take half of the previous y values. So what does that mean for us if we have 1/3? Well, let's take a look here. If we had the 3x, 3 to the x, and the 1 to the 3rd, let's compare those. Look at their graphs. There is the 3 to the x, a little steeper, and here is the 1/3 to the x. Perfect reflections. Here we are multiplying each time by 3. We are increasing by multiples of 3, but here we are going down by thirds. Let's take a look here. See, at 81, take 1/3 of that, it's 27. Take 1/3 of 27, it is 9. Take 1/3 of 9, it is 3. You could also think of this as dividing by 3. So 27 divided by 3 is 9. 9 divided by 3 is 1. 3 divided by 3 is 1. So these b values, they are going to tell you the rate in which your graph is either increasing or decreasing.